This is video 2 of the final year project Smart Road Collision Detection and Notification System. In this video, we will be discussing about the modifications, how far we have come, product components and a further explanation of the components, and how we have overcome the problems. 3 major modifications have been done. The first one is, in order to increase reliability, new sensors are added, considering new parameters. The first sensor is the triple axis accelerometer module. From this sensor, we'll be able to identify the acceleration drop or the deceleration and also the angle of the vehicle at the moment, which will be crucial in identifying whether the vehicle is toppled or not. The second sensor is the IR proximity sensor. From this sensor, we'll be able to identify whether the vehicle has been met with an obstacle. The third sensor is the limit switch. We have used the limit switch for 2 different purposes, and that will be explained further in the presentation. The second modification is the signal from the airbag will be taken through a limit switch, not the wire that goes to the dashboard. The third modification is the placement of the newly added sensors in the vehicle. This will be explained in our next video. These are the product components that we'll be using in our project. We have used 4 IR proximity sensors, 2 at the front of the vehicle, 2 at the back of the vehicle, and we have used 7 limit switches. 3 limit switches will be used at the front of the vehicle and 3 limit switches will be used at the back of the vehicle, and 1 limit switch will be used in identify the signal from the airbags. And we have used 1 triple axis accelerometer module and 1 Arduino board, 1 GPS sensor and 1 GSM sensor. And these components will be further explained by my friend.
GSM, also known as Global System for Mobile Communication, is a technology used to transmit data to a remote device. GSM technology is widely used in the modern world. It uses a variation of time division, multiple access, and is one of the most used of the 3 digital wireless telephone technologies along with TDMA and CDMA. GSM modules are very economic. In this system, the GSM module is used to send the message to the user-defined number in the SIM card. By the help of this, the message will be easily sent to the people who are ready to help. The Arduino Uno is the fundamental platform used for this device. It is built by the Arduino company and is an open source microcontroller which has the Atmega 328P microchip in it. The Uno board has 6 analog and 14 digital input-output pins, which can be connected to circuits and various types of expansion boards. Out of the 14 digital input-output pins, only 6 are capable of pulse width modulation. The Arduino board can be easily programmed using the Arduino IDE software, and the power to the board can be given from a USB cable or a 9-volt battery. GPS is a satellite-based navigation system which sends and receives radio signals to get its current location. GPS technology uses 24 satellites orbiting around the Earth to identify its location. Therefore, the received location is accurate as possible. It is also very cost-efficient and a low-power satellite-based module. We will be using the GPS module to track down the vehicle. When an accident takes place, the GPS system will track the location of the vehicle and will send the information to the receiver through the GSM module. An accelerometer is an electromechanical device which can measure acceleration forces. The forces may be static like gravity or, as in the case with mobile devices, dynamic, which can sense movements or vibrations. The following accelerometer module, ADXL362, is a triple axis accelerometer which can measure gravitational acceleration in X, Y and Z axis. We will be using this module in our system to detect a sudden acceleration drop of the vehicle so that we can say a collision has occurred. This module can also measure the angle which the vehicle is placed, which becomes an important factor if the vehicle has toppled. The IR proximity sensor will detect the presence of an object when the object is within the sensor's field. The proximity sensor will emit a beam of electromagnetic radiation and look for any changes in the return signal. In this system, the proximity sensor is used to detect if the vehicle is in contact with an obstacle. We have planned to place 2 proximity sensors in the front of the vehicle's body and 2 in the back. And at last we have the limit switch. which can be used to detect the existence of an object. When the limit switch is pressed due to an object, the conducting contacts will move, which makes the switch to close or open the electrical connection, depending on the current situation. In this scenario, we will be using 7 limit switches. 6 will be placed in the vehicle's body, 3 in the front and 3 in the back, and 1 will be placed in the dashboard, which will be pressed when the airbags are deployed.
How we have overcome the problems are as follows. The first problem was when vehicle faults such as faults in the airbag or the control unit occur. Since readings from the sensors will not depend on the signals from the vehicle and more than one parameter will be considered in identifying where an accident occurs, this problem will be avoided. The second problem is when problems with sensors occur, this will result in the signal going undetected. In this case as well, by considering more than one parameter, single point of failure will be avoided. Hence, even if one signal goes undetected, it will be captured by another sensor with another parameter, which will result in detecting the crash. The third problem is selecting the correct models for the sensors. After thorough reading about the materials, we were able to identify the correct sensor modules as well as referring to the researchers done similar to this project. We have been able to identify the correct sensor modules. That is the end of our presentation. Thank you.